Okay, so hello everyone. So today, uh, group 6 will be presenting about sampling. So these are the group members. So my name is Cinta, and there will be also Devita, Fadila, and Shabrina. So first we will be explaining about sampling and qualitative research from the Sekaran book from chapter 13. So first I will be explaining about population, elements, sample, sampling unit, and subject. So the population refers to the entire group of people, events, or things of interest that the researcher wishes to investigate. It is the group of people, events, or things of interest for which the researcher wants to make inferences. Next is element. So an element is a single member of the population. So for example, if 1,000 blue-collar workers in a particular organization happen to be the population of interest to a researcher, each blue-collar worker therein is an element. If 500 pieces of machinery are to be approved after inspecting a few, there will be 500 elements in this population. Incidentally, the census is a count of all elements in the human population. Next is sample. A sample is a subset of the population. It comprises some members selected from it. In other words, some but not all elements of the population form the sample. So if 200 members are drawn from a population of 1,000 blue-collar workers, these 200 members from the sample for the study. That is, from a study of these 200 members, the researcher will draw a conclusion about the entire population of 1,000 blue-collar workers. Next is sampling unit. So the sampling unit is the element or set of element that is available for selection in some stage of the sampling process. Like for example, of sampling unit in a multi-stage sample are city blocks, households, and individuals within the household. And the last is subject. A subject is a single member of the sample, just as an element is a single member of the population. If 200 members from the total population of 1,000 blue-collar workers from the sample for the study, then each blue-collar workers in the sample is a subject. So next I will be explaining about the sample data and population values. In sample, the sample units will give response, which then we examine using statistics. The reason we sample is to analyze the characteristic of the population we sample. Yet, to calculate the population, we can't use statistics, which is why we use the parameter of population instead. So, what is parameters? So, parameters is the characteristics of the population, which consists of the population mean, standard deviation, and variance. The central tendencies, the dispersion, and other statistics in the sample of interest to the research are treated as an approximation of the central tendencies, dispersion, and other parameters of the population. Therefore, all conclusions drawn from the samples are generalized to the population. In other words, the sample statistics are used as estimates of the population parameters, as can be seen from the picture. So, sample will estimate the population, and from the population we can get the sample. And next is the representative of sample. So it is common that most samples don't have the exact replica of the population. For example, very few sample means are likely to be exactly equal to the population means, nor is the standard deviation of the sample likely to be the same as the standard deviation of population. However, we choose this sample in a scientific way, we can be reasonably sure that the sample statistic is fairly close to the population parameter, which is why representatives in sample is used to choose sample that has possible similarities to the real population. There is always a slight probability, however, the same values might fall outside the population parameters. Next is normality of distributions. So, attributes of population are mostly normally distributed. If we are to estimate the population characteristic from those represented in a sample with reasonable accuracy, the sample has to be chosen. If we take a sufficiently large number of samples and choose them wisely, we will have a sampling distribution of the means and that has normality. The next is the sampling process. The sampling process consists of 5 stages. The first is defining the population. In order to choose a sample, we have to choose the right targeted population that suits our needs. The target population must be defined in terms of elements, geographical boundaries, and time. For instance, for a banker interested in saving habits of blue-collar workers in mining industry in the United States, the target population might be all blue-collar workers in that industry throughout the country. The second stage is determining the sample frame. The sample frame is a representation of all the elements in the population from which the sample is drawn. The payroll of an organization would serve as the sampling frame if its members are to be studied. Although the sampling frame is useful in providing a listing of each element in the population, it may not always be a current, up-to-date document. The third is determining the sampling design. So there are two major types of sampling designs, which are probability and non-probability sampling. In probability sampling, the elements in the population have some known non-zero chance or probability of being selected as sample subjects. But in non-probability sampling, the elements do not have a known or predetermined chance of being selected as subjects. The fourth is determining the appropriate sample size. The decision about how large the sample size should be can be a very difficult one. We can summarize the factors affecting decisions on sample size, which consists of the research objective, the extent of precision desired, the acceptable risk in predicting that level of precision, the amount of variability in the population itself, and the cost and time constraint, and last is the size of the population itself. The last stage is executing the sampling process. In this final stage of the sampling process, decisions with respect to the target population, the sampling frame, the sample technique, and the sample size have to be implemented.
In non-probability sampling designs, the elements in the population do not have any probabilities attached to their being chosen as sample subjects. This means that the findings from the study of the sample cannot be confidently generalized to the population. So non-probability samplings, there are two, which the first one is the convenience sampling. It refers to the collection of information from members of the population who are conveniently available to provide it. So there is no specific group of population. So convenience sampling is most often used during the exploratory phase of a research project and is perhaps the best way of getting some basic information quickly and efficiently. So the second one is purposive sampling. So instead of obtaining information from those who are most readily or conveniently available, it might sometimes become necessary to obtain information from specific target groups. The sampling here is confined to specific types of people who can provide the desired information, either because they are the only ones who have it or they conform to some criteria set by the researcher. This type of sampling design is called purposive sampling, and the two major types of purposive sampling are the judgment sampling and quota sampling. So the first one is judgment sampling. It involves the choice of subjects who are most advantageously placed or in the best position to provide the information required. For instance, if a researcher wants to find out what it takes for women managers to make it to the top, the only people who can give first-hand information are the women who have risen to the positions of top managerial positions. Judgment sampling may curtail to generalizability of the findings due to the fact that we are using a sample of experts who are conveniently available to us. However, it is the only viable sampling method for obtaining the type of information that is required from very specific pockets of people who alone possesses the needed facts and give the information in organizational settings, and particularly for market research. Opinion leaders who are very knowledgeable or included in the sample, enlightened opinions, views, and knowledge constitute a rich data source. And the second type of purposive sampling is quota sampling. It is a second type of purposive sampling and ensures that certain groups are adequately represented in the study through the assignment of the quota. Generally, the quota fixed for each subgroup is based on the total numbers of each group in the population. However, since this is a non-probability sampling plan, the results are not generalizable to the population. So there are two main types of non-probability sampling: design convenience sampling and purposive sampling. Convenience sampling is the least reliable of all sampling designs in terms of generalizability, but sometimes it may be the only viable alternative when quick and timely information is needed, or for exploratory research purposes. So purposive sampling plans fall into two categories: the judgment and quota sampling designs. Judgment sampling, though restricted in generalizability, may sometimes be the best sampling design choice, especially when there is a limited population that can supply the information needed. Quota sampling is often used on considerations of cost and time, and the needed to adequately represent minority elements in the population. Although the generalizability of all non-probability sampling designs is very restricted, they have certain advantages and are sometimes the only viable alternative for the researchers. Here are the compare and contrast of probability and non-probability sampling designs. You can pause the presentation and read it to better understand. Next one. So depending on what type of research, there are some samplings that is preferred to do different types of research. And the non-probability sampling has been discussed earlier. So next, we discuss about the issues of precision and confidence in determining sample size. Precision refers to how close our estimate is to the true population characteristic. Usually, we estimate the population parameter to fall within a range based on the sample estimate. Precision is a function of the range of variability in the sampling distribution of the sample mean. That is, if we take a number of different samples from a population and take the mean of each of these, we will usually find that they are all different, are normally distributed, and have a dispersion associated with them. The smaller this dispersion or variability, the greater the probability that the sample mean will be closer to the population mean. We need not necessarily take several different samples to estimate the variability. So as we can see, this is the equation for precision, where S is the standard deviation of the sample, the small n is the sample size, and the Sx indicates the standard error or the extent of precision offered by the sample. Note that the standard deviation varies inversely with the square root of the sample size. Hence, if we want to reduce the standard error given a particular standard deviation in the sample, we need to increase the sample size. While confidence, whereas precision denotes how close we estimate the population parameter based on the sample statistics, confidence denotes how certain we are that our estimates will really hold the true for the population. So in essence, confidence reflects the level of certainty with which we can state that our estimates of the population parameters based on our sample statistic will hold true. The level of confidence can range from 0 to 100. So a 95% confidence is the conventionally accepted level for most business research, most commonly expressed by denoting precision and confidence are important issues in sampling because when we use sample data to draw inferences about the population, we hope to be fairly on target and have some ideas of the extent of possible error. Because a point estimate provides no measure of possible error, we do an interval estimation to ensure a relatively accurate estimation of the population parameter. Statistics that have the same distribution as the sampling distribution of the mean are used in the procedure using a z or a t statistics. We could construct a confidence interval around x to estimate the range within which mu will fall. The standard error xx and the percentage or level of confidence we require will determine the width of the interval, which can be represented by the following formula. Where k is the t statistics for the level of confidence desired. So if we see the table, for example, for 90% of confidence level, the K value is 1.945. For 90% confidence level, the K value is 1.96. And for the 99% confidence level, the K value is 2.576. So in sum, the sample size, or a small n, is a function of the variability in the population, the precision or accuracy needed, confidence level desired, and the type of sampling plan used. For example, simple random sampling versus stratified random sampling. So the trade-off between confidence and precision. We have noted that if we want more precision or more confidence or both, the sample size needs to be increased unless, of course, there is very little variability in the population itself. However, if the sample size cannot be increased for whatever reason, then with the same sample size, the only way to maintain the same level of precision is to forsake the confidence with which we can predict our estimates. That is, we reduce the confidence level or the certainty of our estimate. This trade-off between precision and confidence level is illustrated down below, where it indicates that 50% of the time the true mean will fall within the narrow range indicated in the figure, the 0.25 in each tail representing the 25 non-confidence or the probability of making errors in our estimation in either side. The B indicates that 99% of the time we expect the true mean of mu to fall within the much wider range indicated in the figure, and there is only 0.005% chance that we are making an error in this estimation. That is, in figure A, we have more precision but less confidence. In figure B, we have high confidence but we are far from being precise. That is, our estimate falls within a broad interval range. It thus becomes necessary for researchers to consider at least 4 aspects while making decisions on the sample size needed to the research. The first one is how much precision is really needed in estimating the population characteristics of interest, that is, with what is the margin of allowable error. The second one is how much confidence is really needed, that is, how much chance can we take of making errors in estimating the population parameters. The third one is to what extent is the variability in the population on the characteristic investigated. And the last one is what is the cost-benefit analysis of increasing the. So far, we have discussed sample data as a means of estimating the population parameters, but sample data can also be used to test hypotheses about population values rather than simply to estimate population values. The procedure for this testing incorporates the same information as an interval estimation, but the goals behind the two methods are somewhat different. From Chapter 5, we know that we should first set the null hypothesis. The alternate hypothesis of differences will be stated non-directionally. So as per usual, we state our hypothesis equation, the equals 0 and not equals to 0, and to determine we must first find the probability or likelihood of the two groups means having a difference in the context of the null hypothesis or a difference of 0. This can be done by converting the difference in the sample means to a t-statistics and seeing what the probability is of finding a t of that value. So this is the equation for the t statistic. So it means that t value of the result of the t value, whether it's below or above the value, will definitely result in a different outcome and resulting in a different conclusion. Sample data can thus be used not only for estimating the population parameters, but also for testing hypotheses about population values, population correlation, and so forth. So both sampling design and the sample size are important to establish the representativeness of the sample of generalizability. If the appropriate sampling design is not used, a large sample size will not in itself allow the findings to be generalized to the population. Likewise, unless the sample size is adequate for the desired level of precision and confidence, no sampling design, however sophisticated, will be useful to the researcher in meeting the objectives of the study. Hence, sampling decisions should, with too large of a sample size, it could be a problem in as much as we would then be prone to committing type 2 errors. That is, we would accept the findings of our research when in fact we should reject them. In other words, with too large a sample size, even weak relationships, say a correlation of 0.1 between two variables, might reach significant levels, and we would be inclined to believe that these significant relationships found in the sample were indeed true of the population, when in reality they may not be. Thus, neither too large nor too small sample sizes help research projects. Another point to consider is even with the appropriate sample size is whether statistical significance is more relevant than practical significance. For instance, a correlation of 0.25 may be statistically significant, but since it explains about 6% of the variance, how meaningful is it in terms of practical utility? So Roscoe proposes the following rules of thumb for determining sample size. The first one is sample sizes larger than 30 and less than 500 are appropriate for most research. The second one is where samples are to be broken in subsamples, for example, males or females, juniors or seniors, etc. A minimum sample size of 30 for each category is necessary. The third one is multivariate research, including multiple regression analysis. The sample size should be several times, preferably 10 times or more, as large as the number of variables in the study. The fourth one is for simple experimental research with tight experimental control. A successful research is possible with samples as small as 10 to 20 in size. So, efficiency in sampling is attained when, for a given level of precision or standard error, the sample size could be reduced, or for a given sample size, the level of precision could be increased. Some probability sampling designs are more efficient than others. The simple random sampling procedure is not always the most efficient plan to adopt. Some other probability sampling designs are often more efficient. There is often a trade-off between time and cost efficiencies as achieved in non-probability sampling designs and precision efficiencies as achieved in many probability sampling plans. The choice of sampling plans thus depends on the objectives of the research as well as on the extent and nature of efficiency desired.
Okay, next I'm going to explain about sampling in qualitative research. Okay, so sampling in qualitative research is, hold on. Okay, so sampling in qualitative research is just as important as sampling for quantitative research. So what do we use in qualitative research then? So apparently qualitative sampling begins with precisely defining the target population. So as a sampling technique, qualitative research generally uses non-probability sampling as the technique does not aim to draw statistical inference. And then the type of non-probability sampling that we use is purposive sampling, which is already explained earlier by my colleague. But purposive sampling is one technique that is often employed in this qualitative research, which subjects are selected on the basis of expertise in the subject that is being investigated. So, for example, when you are conducting a research about Apple customers, then you do the research, you do the sample to the people that are using Apple products, not the people who use like other products than Apple, because that is way more relevant for you and you want to know like what their take on the products. Okay, and that's for purposive sampling. One form of purposive sampling is called theoretical sampling. So theoretical sampling also express the term called grounded theory, which means that the idea that theory will emerge from data through an iterative process that involves repeated sampling, collection of data, and analysis of data until theoretical saturation is reached. So basically, theoretical sampling or grounded theory will the repeated the continuity of data collection until we reach theoretical saturation. And when do we reach theoretical saturation? We do reach theoretical saturation when no new information about this subject emerges in repeated cases. So it is actually impossible to predict when theoretical saturation is reached. We cannot determine how many subjects will be need to be sampled at the beginning of our study. So instead, the general rule in qualitative research is that we continue to sample until we are not getting any new information or are no longer gaining new insights. So for theoretical saturation, we just need to keep doing the research until we no longer gain new insights from the research or from our samples. So that's it for sampling in qualitative research. We can move on to the role of the manager in sampling. So actually there are 5 roles of managers in sampling from this current book that I note down. The first one we get like the managers the purpose or the role of managers is to understand why a sampling method is used by researchers. So by understanding the role of managers, the role of researchers, managers can also understand why a sampling method is used, like why do their company uses quantitative method, for example, why do they use non-probability, for example, purposive sampling. The managers will then understand, and then he also can understand the cost implication of different designs. So, for example, if conducting probability sample will be much more expensive than non-probability sample, but why? The manager needs to know why conducting purposive sampling is needed, and then why it is a little bit costly than non-probability. And then The managers need to understand the risk taken in implementing changes from the research. So basically, the research is conducted in order to know what is lacking or what is missing in the company. And then the result of the research is then being implemented into the company. So the managers need to understand the sampling, how the research goes, in order to understand okay, so if we're doing this, then the risks are going to be this, and then they can easily take it into implementation, the research result into implementation. And then the fourth one is to help assess the generalizability of the findings, and the fifth one is help analyze the implications of recommendations. So these 2 points are basically also emerge from the result of research. Next, we'll be moving on to the next reference book, which is the Cooper chapter 14. So I'm going to explain the first part of the Cooper chapter 14 book. We have the nature of sampling. So the basic idea of sampling is that by selecting some of the elements in a population, we may draw conclusions about the entire population. So I'm going to further explain what is population element, population, and what does differ population or sampling from census. So a population element is the individual participant or object on which the measurement is taken. It is basically the unit of study. So when we do a sample, we mostly sampling the population element. Although an element may be a person, it can also be anything else. For example, in your company, the members of your company is questioning about an optional promotional strategy. For example, that the optional promotional strategy can also easily be your population element. For example, each advertising account analyzed is an element of an account population, and each advertising is an element of a population of advertisement. So the population element is basically the targeted group of our sample, of our research within a population. And then a population is the total collection of elements where we wish to make some inferences. So, for example, all students in Faculty of Economics and Business compose a population of interest. We have nearly 7,000 of students. So all 7,000 students define a population of interest, for example. And then a census is a count of all the elements in a population. If 7,000 students divide the population, a census would obtain information from every one of them. Census means that we interview every single one of the population elements. So yeah, and then we call the listing of all population elements from where the sample is drawn as the sample frame. Okay, and that's it for the nature of sampling. Next, I'm going to explain the reasons behind why the researchers do sample. Why is sampling better? And then there are actually 4 reasons behind this. So first, we have lower cost. So compared to conducting a census, the comparison, the economic advantage of taking a sample rather than a census are massive. Consider the cost of taking a census. For example, if we want to make the whole students of Faculty of Economics of Business as our target. So we do a census in Faculty of Economics and Business. It will also be like very, very costly. Like rather than that, we can just, for example, our research is about the relation between Faculty of Economics and Business students with their usage of Android, for example. So we just need to sample from those who are the students of Faculty of Economics and Business that uses Android, and it will be much more relevant because if we interview those who are using other than Android, it will be just a waste of time, a waste of cost. And then we have the second one, which is the greater accuracy of results. So it will be way more accurate. It will be way more relevant for our study because we know who are we sampling. We know who our targeted samples are. Again, I'm going to take an example of the Faculty of Economics and Business students and Android. For example, if we take census, it will be like the people who are not using Android will also be included, and it will be not accurate for our research. And then we have greater speed of data collection. So through sampling, for example, now that we are all home and most of our research groups in our class will be conducting their sampling using Google Form, for example, or Typeform, and distribute it through social medias. If we do census to like each of the students in Faculty of Economics and Business, which may not be relevant, it will also take so much more time than just, oh, so you're an Android user, here's a form for you to fill, please help my study. That. And then lastly, we have availability of population elements. So we know that the population element exists. We just need to take like a good amount of people from the group to be our sample, for example. We know that the population element of the students at Faculty of Economics and Business exists, and then we just need to take a couple of people who uses Android in order for it to be relevant to our study. So that's it for why sample. We'll be moving on to our colleague's explanation regarding what is a good sample.
Next, what is a good sample? The ultimate test of a sampling design is how well the sample represents the characteristics of the population that it represents. Therefore, it must be valid, and the validity depends on the accuracy and the precision of the sample. First, the accuracy. It is the degree to which bias is absent from the sample, because samples might underestimate and overestimate population values, and an accurate or unbiased sample is one in which the underestimators offset the overestimators. Systematic variance is the variation in measures due to some known or unknown influences that cause the scores to lean in one direction more than another. And decreasing the error that caused by systematic variance, it could be done by increasing the sample size. Next is the precision, which is the second criterion of a sample design. Researchers accept that no sample will fully represent its population in all respects. Therefore, there is need to measure how closely the sample represents the population. The numerical descriptors that describe samples may be expected to differ from those that describe populations because of random fluctuation inherent in the sampling process. This is called sampling error, or the numerical fluctuations in the sampling process. The precision is measured by the standard error of estimate, where the smaller the standard error of estimate, the higher the precision. Next is the types of sampling design, and here the picture illustrates the sampling design within the research process. So first, it starts with the management research question hierarchy and ends with drawing samples. So there are options for researchers to draw the sample for their research. There are two types of sample design or two approaches. So the first one is representation, that is divided by two. The first one is non-probability sampling, which is an arbitrary and subjective one. So each member of the population does not have a known chance of being included, and it is a non-random sampling. And the second one is probability sampling. It is based on the concept of random selection, a controlled procedure that assures that each population element is given a known non-zero chance of selection. And then the second approach is the element section. It may classify samples. If each sample element is drawn individually from the population at large, it is called unrestricted sample, while the restricted sample covers all the other forms of sampling. There are five steps of sampling design. The first one is, what is the target population? So target population is the collection of elements and objects that possesses the information sought for research. So here the researchers have to know or have to define their target population first. For example, is the current student of UI. And the second step is, what are the parameters of interest? The population parameters is summary descriptors of variables of interest in the population, while sample statistic descriptors is descriptors of those same relevant variables computed from the sample data itself. For example, the frequency of eating on or near campus within the last 30 days. And the third step is, what is the sampling frame? It is the elements from which the sample is actually drawn. It is the list of all those people or individuals or institutions within a population who can be sampled. For example, it is a more narrow one. It's the current students who frequently ate near campus within the last 30 days. The fourth step is, what is the appropriate sampling method? It is when the researchers choose whether to do the sampling method by probability or non-probability sample. And in here, sampling error is likely to arise. And then the last one is, what is the appropriate sampling method? So principles influencing the sampling size is the greater dispersion or variance within the population, the larger the sample must be to provide estimation precision. The greater the desired precision of the estimate, the larger the sample must be. And the narrower or smaller the error range, the larger the sample must be. And in here, cost consideration influence the sampling method. Next, we are going to talk about the probability sampling approach. The first approach is the simple random sampling. So it is considered as a special case in which each population element has a known and equal chance of being selected into the sample. We can know the probability of selection by dividing sample size with population size. So the sample here is drawn using random number table, which contain digits that have no systematic organization. And how to choose a random sample? First, we assign each element within the sampling frame a unique number from, identify a random start of the random number table, determine how the digits in the random number table will be assigned, and select the sample elements from the sampling frame. However, this method or this approach can be impractical most of the time. The second approach is the complex probability sampling. Since simple random sampling is often impractical, so there are other approaches. The alternative probability sampling approaches considered, there are four. The first one is systematic sampling, stratified sampling, cluster sampling, and double sampling. So the systematic sampling, so in this approach, every kth element in the population is sampled, beginning with the random start of an element in the range of 1 to k. So K is the skip interval between the samples. So we divide the population size with the sample size. And to draw a systematic sample, do the following steps. The first one is identify, list, and number the elements in the population. Identify the skip interval or K. Identify the random start. And draw a sample by choosing every kth entry. The second approach is the stratified sampling. So the population is segregated into several mutually exclusive subpopulation or strata. There are three reasons a researcher chooses a stratified random sample. The first one is to increase a sample's statistical efficiency, and then to provide adequate data for analyzing the various subpopulation or strata, and then to enable different research methods and the procedures to be used in the different strata. So the stratified sampling is the study of the characteristics of the subgroups. And the size of strata samples is calculated with how large the total sample will be and how the total sample should be allocated among strata. And then we can do the stratified sampling through the process. First is determine variable, determine proportion to variable, select proportionate or disproportionate stratisfaction based on the project information needs and risk, divide sampling frame into separate frames, and randomize the elements within each stratum sampling frame. And then the last one is to follow random or systematic procedures to draw a sample from each stratum. As we talk about the process for drawing a stratified sample, there's a step where the researchers can select the proportionate or disproportionate stratisfaction based on project information needs and risk. So proportionate sampling is where each stratum represented is properly represented so that the sample size drawn from the stratum is proportionate to the stratum's share of total population. Some reasons to use this approach is because it has a higher statistical efficiency than a random sample, and then it is much easier to carry out, and then it provides self-weighting sample. And then the second one is the disproportionate stratified sampling. So actually, there are several schemes, but we can choose one here. One type is the judgmentally determined disproportion. It is based on the idea that each stratum is large enough to secure adequate confidence level and error range estimates for individual strata. The third approach is the cluster sampling. So in here, the population is divided into internally heterogeneous subgroups. There are two conditions that first foster the use of cluster sampling. The first one is the need for more economic efficiency than can be provided by simple random sampling, and the frequent unavailability of a practical sampling frame for individual elements. So much research involves a population that can be identified with some geographic area. When this occurs, it is possible to use area sampling. It is a technique applied to a population with well-defined boundaries, such as country populations, national populations, and even smaller areas. So it requires low cost and it is frequently used. And in designing cluster samples, including area samples, we must answer several questions about the design. The first one is how homogeneous are the resulting clusters? Shall we seek equal size or unequal size clusters? And how large a cluster should we take? And shall we use a single stage or multi-stage cluster? And how large a sample is needed? And then the last approach is the double sampling. It may be more convenient or economical to collect some information by sample and then use this information as the basis for selecting subsample for further study. And double sampling is oftenly called double sampling, sequential sampling, or multi-phase sampling. And here is the comparison of probability sampling designs, including the 5 types, each description, and advantages and disadvantages.
Okay, and lastly, I'm going to explain about non-probability sampling as written in the Cooper chapter 14. I believe in sekarang we have like a slight difference, which I'm going to be explaining next. First, I'm going to give a brief explanation about why non-probability sampling is considered, can also be more considered than probability sampling. So we may use non-probability sampling procedures because they satisfactorily meet the sampling objectives. We do have an objectives for our sample, and through non-probability sampling, we can easily target our samples. After researchers have more limited objectives, they may be looking for only the range of conditions or, for example, of variations. Other reasons for choosing non-probability sampling is probability sampling calls for more planning and repeated callbacks, which is more expensive. So in probability sampling, like you need to plan, you need like a major plan. You need like a thorough plan, and then you need to always make sure that your sample is responding to you. So that is way more costly. And then probability sampling also takes more time, since researchers have to ensure that each selected sample member is contacted. In certain cases, the population may not be feasible to study, so we use non-probability sampling to just draw a group from the population, and then we look for the ones that are relevant to our study. And then the samples of the non-probability method has the option to do self-select, which means that they can decide, like the samples can decide whether they want to be the samples of this research or not. Next, we have the methods of non-probability sampling. So I believe in the sekarang book, it only explained the purposive sampling. I don't believe like they explain about convenience and snowball sampling. So I'm going to give like a thorough explanation regarding the two. So convenience sampling lives up to its name, convenience. So the unrestricted samples. It is the least reliable design, but the cheapest and easiest to conduct. So actually, convenience sample is where a method where the sample is taken from a group of people that are easy to contact or to reach. So again, it lives up to its name, convenient. For example, the people who are approaching us at malls or grocery stores, approaching us to fill a survey or answer questions, it will be a type of convenience sample. It can also be known as grab sampling or availability sampling. There are no other criteria to the sampling method except that people be available and willing to participate. So this type of sampling method does not require that much like difficult questions. We just need like the samples who are willing to answer. So again, it is the least reliable, but it's the easiest to conduct since you can like approach people in random places, and it's also cheap because you don't need to distribute a form or anything like that. And then we have purposive sampling, which I believe I have already explained by my colleague. Purposive sampling is a non-probability sample that conforms to certain criteria, and like it has the purposive sample, like it has a targeted sample. So we have judgment sampling, where the researcher selects sample members to conform to some criteria. It basically in an expertise, I believe, and then quota sampling is used to improve representativeness. And for purposive sampling, that is it. We have next snowball sampling. So snowball sampling is when the respondents are difficult to identify and are best located through referral networks. So basically, individuals discovered and selected is used to refer the researcher to others who possess similar characteristics. So basically, the first step to snowball sampling is we approach individuals that are discovered may or may not be selected through probability methods. And then these individuals that we approach first will then refer us as the researchers to others who possess similar characteristics, and then it's basically like snowball. So they refer us to other people, and then other people recommend us to other people that also possess the similar characteristics that we are looking for in order to complete our study. And so that it is for our presentation. Do you have any question? Please let me know in the comments. Thank you so much for listening and tuning in. So sorry if we make a lot of mistakes. Thank you. Good day.